Today we are going to focus on two major points. One is gravitational constant and another is consequences of gravitation. But before the gravitational constant, at least we must have a little idea about Newton's law of gravitation. That's why I want to start with Newton's law of gravitation. According to Newton's law of gravitation, the gravitational force between any two bodies is directly proportional to the product of their masses and inversely proportional to the square of the distance between their centers. It means gravitational force depends upon two physical quantities. One is mass, another is distance, and when mass increases, gravitational force increases, and when distance increases between two bodies, then gravitational force decreases. This is the formula obtained by the Newton's law of gravitation, which can be used to solve numerical problem related to gravitational force between two bodies. Okay, what is gravitational constant now? This is very interesting. It is denoted by capital G. We don't have to forget this. What is it? Let's say this is 1 kilogram mass. This is another 1 kilogram. It means we have two unit masses and they are separated by a unit distance, and all the units are taken according to SI system. Two unit masses are separated by unit distance. The force of attraction between these two unit masses separated by unit distance is called actually gravitational constant. And according to SI system we are taking these units, but we can take two 1 gram masses also and we can separate them with 1 centimeter distance. The main point is when two unit masses are separated by a unit distance, the force of attraction between them is gravitational constant, and it is defined like this. The force of attraction between two unit masses separated by a unit distance is called gravitational constant. It is denoted by symbol G, capital G, and its value is 6.67 into 10 to the power minus 11 Newton meter square by kg square. Look at this value. This value of gravitational constant is very important. We have to use this value to solve numerical problem of gravitational force. That's why you have to remember this with unit. This is a constant, but I think you remember this when we derived F equal to ma. At that time one of the constant was there, that was k, but k was removed at that time. But here in this case gravitational constant g is not removed in the equation. In F equal to kma, now I want to take k in one of the side, then what happens? K is equal to F upon m into a. If we take unit of all these physical quantity, then force is unit is Newton, mass is unit is kilogram, and acceleration is unit is meter per second square. The expanded form of Newton is kg meter per second square, and it is in numerator, and in denominator also we have kg meter per second square. Now these two cancel each other, then the value of k becomes 1. If value of k becomes 1, why should we take k in this equation? Because 1 is if multiplied by mass and acceleration, then the product will be mass into acceleration only. That's why instead of writing k ma, we can use F equal to ma. In this case the value of this constant is 1, that's why we remove this. But in case of gravitation it is different. We have F equal to g m1 m2 by d square, and g is the constant. And if all the physical quantities are represented by their unit, force by Newton, mass by kilogram, and distance by meter, then we will have this Newton equal to g kg into kg upon meter square. And if g is taken to one of the side, meter square goes to left hand side, Newton into meter square, and kg into kg goes down in denominator, then we have this expression. Now after this, look at this. Newton is again expanded here, kg meter per second square we know, and kg if cancelled, then we will have meter per second square into meter square upon kg. One of the kg is cancelled. Now we have to multiply meter square with meter cube upon second square, and kg. If we take all of them in numerator, then meter cube kg to the power minus 1, kg is in denominator. If it is taken to numerator, then its power will be minus 1, and this second is in denominator. That's why if it is taken to numerator, second to the power minus 2. Now we cannot reduce more than this. All the units are now converted into basic unit, fundamental unit. That's why the value of g never comes 1. If value of g is not 1, then we cannot remove this g from this equation. But in previous case, value of k was 1. That's why it was removed. But value of capital G is not 1. So it has certain value and it is taken in the equation. Now I want to tell you about this 6.67 into 10 to the power minus 11 Newton meter square by kg square. Exactly what it means. If g has this value, it means 6.67 should be divided by 10 to the power 11. It is in numerator, that's why minus 11. Now it is taken to denominator, then we will have 10 to the power 11. It means we have to divide this with 10 to the power 11. It means 6.67 is, if divided by 10 to the power 11 means 1 having 11 0, then this is very small number. More than 6, less than 7. And this small number is if divided by this huge number, then we will have certainly very small number. This 0.000000 and then comes 667. It is millions of millions time less than 1. And the meaning of this value is when two 1 kg masses are separated by 1 meter distance, then the force of attraction between them is very less, and it is equal to this value 6.67 into 10 to the power minus 11. What is the meaning of this? It means when two 1 kilogram masses are separated by 1 meter distance, then the attraction force between them is very less. That is equivalent with this value. Okay, let's go forward. Who found this value? It was declared by Henry Cavendish. And this is Cavendish balance. It is very big balance, and he set this balance in a room. And with the help of this balance, he found the value of G, capital G. Okay, now another important question. In which condition the value of G will be equal to gravitational force? Gravitational force is F. In which condition? We have to show it with mathematical process. Okay, this way we can show. According to Newton's law of gravitation, F equal to G m1 m2 by d square. And this is the first mass m1, second mass m2, and they are separated by a distance d from center to center. And we can take the value also as shown in the diagram. If m1 equal to m2 equal to 1 kilogram and d is equal to 1 meter, then F will be equal to capital G. This m1 is 1, m2 is 1, and d is also 1. F equal to G, 1 into 1 divided by 1. It means F is equal to G. This is the condition. What it means? Therefore, gravitational force between two unit masses separated by the unit distance is equal to capital G. Now let's go through another part we have targeted today. It is consequences of gravitation. Do you know this? What is shown in this video clip? Millions of millions stars are held together due to the gravitational force of attraction with each other. They formed a galaxy. This is a galaxy which contains millions of stars. And actually they held together due to the force of attraction, that is gravitational force. And our universe is full of these galaxies. There are millions of galaxies present in the universe. That's why what can we say, one consequence, important consequence of gravitation, the major component of universe is galaxy, which is the vast collection of millions of stars, and the universe is full of galaxies. Now another consequence is, look at this diagram. You have seen this many times, I think. This is a video clip. In the center there is sun, and the planets are revolving around the sun. They held together due to the force of attraction between them, and this is gravitational force. That's why, because of the gravitational force, solar system exists. So we can say next consequence, what solar system exists due to the gravitational force. Now third, this diagram is of same place. This is the sea beach and sea water is away. But after every 6 hours, the beach is full of water. And again after 6 hours, it again comes. In this way, a cycle can be seen in the sea beach. Sometimes the level of water rises and sometimes goes down. After every 6 hours, this is a cycle of tide, and this is called tide. The rise and fall of level of water in the sea due to the gravitational force of the moon is called tide. Look at this also. This is the same place, and sometimes it is filled with water and sometimes not filled with water. There is another place also shown. Sometimes water level is high, sometimes less. This way, actually, the one of the great consequence of this gravitational force is tide on the sea forms due to the gravitational force of the moon. When moon comes in front of the sea, then it will pull the water of that sea and the level of water rises. But when the moon is at the angle of 90 degree, then the level of water falls down. This is called low tide, and when level of water rises up, that is called high tide. There is high tide and low tide after every 6 hours. This is because of the gravitational force of the moon acting on the sea water. This is one of the great consequences of gravitational force of the moon. So we can highlight these three major points which can be recognized as consequences of gravitation. Okay, next class we'll meet with some other material